What if I told you that one of the most legendary engines ever created was so dominant that it was essentially banned from competition? Today, we're diving deep into the captivating story of Nissan's RB26DETT engine, the heart and soul of the iconic Skyline GTR, a power plant so formidable that it changed motorsport regulations forever. Welcome to our channel. If you're a car enthusiast, chances are you've heard whispers about the mythical RB26, the straight-six beast that powered Godzilla itself, the Nissan Skyline GTR. But behind the performance figures and the racing pedigree lies a fascinating tale of engineering brilliance, corporate determination, and ultimately regulatory intervention that all but banned this incredible power plant from the racing world. By the end of this video, you'll understand why the RB26DETT isn't just another performance engine. It's a watershed moment in automotive history, a creation so ahead of its time that rulebooks had to be rewritten because of it. So buckle up as we explore the shocking truth behind the engine that became too good for its own good. To understand the story of the RB26DETT, we need to travel back to the late 1980s. After a 16-year hiatus, Nissan was preparing to resurrect the legendary GTR nameplate. The previous generation Hakusuka and Kenmuri GTRs had cemented their place in Japanese automotive folklore, but Nissan wasn't looking to simply continue the legacy. They wanted to redefine it. The automotive landscape had changed dramatically since the last GTR. Competitors had raised the bar considerably, especially with turbocharging technology becoming increasingly prevalent. Nissan needed something special, something that would not only match but exceed what was available on the market. This wasn't just about creating another sports car. This was about restoring national pride. Japan's bubble economy was at its peak, and automakers were engaged in an unprecedented technological arms race. Cost was a secondary consideration to performance and innovation. Nissan's executives gave their engineers a simple but ambitious directive: build the most advanced sports car Japan had ever produced. Enter the RB series of engines. The RB, or race-bred engines, had been a part of Nissan's lineup since the early 80s, powering various Skyline models with displacements ranging from 2.0 to 3.0 liters. But for the new GTR, Nissan's engineers were tasked with creating something extraordinary, an engine that would form the backbone of their renewed motorsport efforts, particularly in Group A touring car racing. The team was led by engineering genius Naganori Ito, who had already made his name developing previous high-performance Nissan power plants. Ito understood that to create something truly special, they would just need to throw the conventional rulebook out the window and embrace cutting-edge technologies that had previously been reserved only for purpose-built race engines. What they created would change the performance car landscape forever. The development wasn't without challenges. Early prototypes suffered from cooling issues and turbo lag. The engineering team worked tirelessly through countless iterations, often testing through the night at Nissan's Tochigi proving grounds. Legend has it that Ito was so committed to perfection that he personally tested each engine configuration, developing an almost supernatural ability to detect the slightest imperfections in engine sound or response. This fanatical attention to detail would ultimately produce one of the most over-engineered production engines in automotive history. The RB26DETT designation breaks down as follows. RB is the engine family. 26 represents the 2.6-liter displacement. D stands for dual overhead camshafts, E for electronic fuel injection, and TT signifies twin turbos. But these letters and numbers hardly tell the full story of what makes this engine so special. Let's start with the basics. The RB26 is an inline-six engine with a cast-iron block and an aluminum head. The 2.6-liter displacement was specifically chosen to meet Japanese tax regulations while also conforming to Group A racing rules, which required engines to be 2.5 liters or less with a turbocharger. Nissan's engineers squeezed in an extra 100 cubic centimeters while still maintaining their competitive advantage. This was no accident. It reflected Nissan's commitment to maximizing performance within regulatory constraints, a philosophy that would define the entire GTR program. The engine features a relatively square bore and stroke ratio of 86 mm by 73.7 mm, allowing it to rev freely to its 8,000 RPM redline. Impressive even by today's standards, and absolutely mind-blowing for 1989. The block itself is extraordinarily strong, with thick cylinder walls capable of handling tremendous power increases. The closed-deck design with solid sleeves provides exceptional rigidity under high cylinder pressures, a feature normally found in dedicated race engines. Each cylinder is lined with cast iron for durability, while the crankshaft is fully counterweighted and made from forged steel to withstand the stresses of high revving operation. But what truly set the RB26 apart was its induction system. Unlike most turbocharged engines of the era that used a single larger turbocharger, Nissan opted for a parallel twin-turbo setup. Two Garrett T28 type ceramic turbochargers, each feeding 3 cylinders, reduced lag and provided more linear power delivery throughout the rev range. This arrangement was revolutionary at the time, addressing the primary criticism of turbocharged engines: unpredictable power delivery and significant lag. The ceramic turbine wheels were lighter than conventional metal alternatives, allowing them to spool up more quickly. Each turbocharger was water-cooled to improve longevity and performance under sustained, high-load conditions. Another feature ahead of its time. Adding to this sophistication was the intake manifold designed with 6 individual throttle bodies, one for each cylinder, a feature typically found only in purpose-built race engines. This arrangement allowed for incredibly precise air delivery and throttle response that felt almost naturally aspirated despite the forced induction. The throttle bodies themselves were 45 mm in diameter, providing substantial airflow capacity even at high RPM. Behind each throttle body sat a 444 cubic centimeter fuel injector, oversized for the factory power levels but providing headroom for future modifications, a recurring theme in the RB26's design. The engine was officially rated at 276 horsepower due to Japan's gentleman's agreement among manufacturers to limit advertised power outputs. In reality, stock RB26 engines routinely dyno tested at well over 300 horsepower, with some reportedly producing as much as 330 horsepower straight from the factory. This deliberate underrating became part of the Skyline mystique. Owners knew they were getting more than what was advertised on paper. The torque curve was another area where the RB26 excelled, delivering over 260 pound-feet from 3,200 RPM to nearly 7,000 RPM. A remarkably flat curve that contributed to the engine's tractability both on road and track. Perhaps most impressive was the engine's robustness and tuning potential. While the stock internals were already overbuilt, the aftermarket quickly discovered that, with relatively minor modifications, the RB26 could safely produce 500 to 600 horsepower. With more extensive builds, 4-digit horsepower numbers became achievable, a testament to how over-engineered the original design truly was. The oil system featured a high-capacity pump and an extra-large sump to ensure proper lubrication, even under extreme cornering forces. The cooling system was similarly over-designed, with a high-efficiency radiator and optimized coolant pathways to prevent the detonation issues that plagued many high-performance turbocharged engines of the era. The RB26DETT found its home in the R32 Skyline GTR, launched in 1989. This was not just another Japanese sports car. It was Nissan's technological flagship, designed with one primary purpose: domination in motorsport. Chief engineer Naganori Ito had directed his team to create a car that would be unbeatable on track, and the RB26 was the centerpiece of this strategy. The engine wasn't designed in isolation. It was developed in conjunction with the advanced chassis and drivetrain systems that would make the GTR a holistic performance machine. The R32 GTR paired the RB26 with an advanced all-wheel drive system called ATTESAETS, Advanced Total Traction Engineering System for All-Electronic Torque Split, and four-wheel steering called HICAS, High Capacity Actively Controlled Steering. This combination of cutting-edge technologies created a car that could outperform vehicles costing several times more. The ATISA system was particularly revolutionary, using electronic control units to vary torque distribution between front and rear axles based on numerous inputs including throttle position, G-forces, wheel speed, and yaw rate. Under normal conditions, the system operated in rear-wheel drive mode for better efficiency and driving feel, but could send up to 50% of power to the front wheels in milliseconds when needed for traction or cornering stability. It's worth noting that the RB26 wasn't just powerful, it was remarkably compact for its output. This allowed Nissan engineers to achieve excellent weight distribution in the GTR, contributing to its phenomenal handling. The engine's relatively narrow inline configuration also helped lower the car's center of gravity compared to V configuration alternatives. At just 26 inches long, the RB26 could be mounted well behind the front axle line, creating a front mid-engine layout that optimized weight distribution. The compact dimensions also allowed room for the complex ATISA ETS transfer case and associated hardware without compromising the car's proportions or interior space. The synergy between the RB26 and the Skyline GTR's chassis was so perfect that it earned the car its famous Godzilla nickname. This wasn't just a marketing term, it was a fearsome moniker bestowed by Australian motoring journalists who witnessed the car obliterating competition on racetracks. Wheels magazine's headline after the GTR's first Australian appearance read simply, "Godzilla," capturing the mixture of awe and fear that competitors felt when facing Nissan's technological tour de force. The name stuck, perfectly encapsulating how this Japanese beast stomped all over established performance conventions. The RB26 would go on to power 3 generations of GTR, the R32, 1989 to 1994, R33, 1995 to 1998, and R34, 1999 to 2002. Throughout its production run, the core design remained largely unchanged, a testament to how right Nissan got it the first time. Minor updates were made over the years, including stronger N1 blocks for later models, improved turbochargers, and refined electronics, but the fundamental architecture remained the same. The R33 GTR received metal, rather than ceramic, turbine wheels for improved durability, along with a slightly revised intake system. The R34 featured the most significant updates, including a more sophisticated engine management system and improved turbochargers with better wastegate control for reduced lag. This consistency allowed the RB26 to develop a devoted following. Tuners, racers, and enthusiasts understood the engine intimately, and knowledge about its potential and limitations was widely shared. The result was a performance ecosystem unlike anything else, with the RB26 at its center. Specialized parts manufacturers emerged solely to service the RB26 market, creating everything from forged pistons to stroker crankshafts, billet intake manifolds to titanium valve trains. This availability of high-quality aftermarket components further cemented the engine's reputation as the ultimate tuner platform, creating a virtuous cycle of development and improvement that continues even decades after production ended. Now we come to the meat of our story, how the RB26DETT became so dominant that it essentially got banned from competition. To understand this, we need to look at the Group A touring car racing scene of the late 1980s and early 1990s. Group A regulations required cars to be based on production models with at least 5,000 examples produced for homologation purposes. The rules were intended to create close competition between modified production cars that spectators could relate to. Cars you could theoretically buy from a showroom. Little did the regulators know that Nissan would turn this concept on its head by essentially creating a purpose-built race car and then selling the required 5,000 units to the public. When Nissan entered the R32 GTR into Japan's Group A Touring Car Championship, they had one goal: crush the competition. What followed was one of the most dominant performances in motorsport history. From 1989 to 1993, the ER32 GTR won every single race it entered in the Japanese Touring Car Championship. 29 consecutive victories, a perfect record. This wasn't just winning, this was annihilation. Competing manufacturers like Toyota, Mazda, and Honda were left battling for second place, with the GTRs often finishing races a full lap ahead of their nearest rivals. The Skyline's combination of the robust RB26 engine, sophisticated all-wheel drive, and advanced aerodynamics created a package that simply couldn't be matched within the existing regulations. But it wasn't just in Japan where the GTR and its RB26 heart were rewriting the record books. When the car was entered in Australia's Bathurst 1000, one of the most prestigious touring car races in the world, it performed so well that it forever changed Australian motorsport. The Mount Panorama circuit at Bathurst had long been the domain of large displacement V8-powered cars, typically Holden Commodores and Ford Falcons. These were simple, rugged machines with a straightforward approach to performance, big engines, rear-wheel drive, and mechanical simplicity. The arrival of the high-tech Skyline GTR was like an alien spacecraft landing among biplanes. In 1990, the R32 GTR won the Bathurst 1000, with Jim Richards and Mark Skaife demolishing the competition. They returned in 1991 and won again, this time by a margin so large that it was embarrassing for the local favorites. The dominance was so complete that Australian racing fans started referring to the car exclusively as Godzilla, the monster from Japan that came to destroy everything in its path. One particularly telling statistic: during qualifying at Bathurst in 1991, the GTR was clocked at 293 kilometers per hour, 182 miles per hour, down the Conrad Straight, while the V8-powered competitors could barely manage 278 kilometers per hour, 173 miles per hour. This 15 kilometer per hour advantage came despite the GTR having less displacement and being restricted by turbo boost limitations. A testament to the fundamental superiority of the RB26 and its associated technologies. The problem for racing organizers was that the GTR wasn't cheating. It was simply built to maximize performance within the existing rules. Its combination of all-wheel drive, twin turbos, and sophisticated electronics made it virtually unbeatable on any circuit in any condition. The RB26 engine itself was a marvel of efficiency, extracting more power per liter than any of its competitors while maintaining reliability through grueling endurance races. Its revvy nature and broad power band meant that GTR drivers could maintain higher average speeds throughout a lap, especially in technical sections where acceleration out of corners became crucial. The response? Rather than continuing to be humiliated by the Japanese machine, Australian touring car racing authorities effectively banned the GTR by changing the rules. They implemented a weight penalty system that added 100 kilograms to turbocharged cars and another 100 kilograms to all-wheel drive vehicles. The Skyline, being both turbocharged and AWD, was hit with a crushing 200 kilogram penalty, the equivalent of carrying an extra passenger around the track. This was a targeted attack on the GTR, as no other competitive car in the series combined both turbocharging and all-wheel drive. The message was clear: we can't beat you on a level playing field, so we'll change the rules until you can no longer compete. Even with this handicap, the GTR continued to win races, including the 1992 Bathurst 1000 in famously wet conditions. This victory was particularly poignant. In a torrential downpour, the GTR's advanced all-wheel drive system proved its worth despite the weight penalty, with Jim Richards and Mark Skaife crossing the finish line first, just as a multi-car pileup brought out the red flag. The race ended in controversy, with the rain-soaked crowd booing the Japanese car on the podium, prompting an angry Richards to famously declare, "This is bloody disgraceful. I thought Australian race fans had more knowledge than this. You're a pack of arseholes." It was a reflection of how deeply the GTR had disrupted the established order and wounded national pride in what Australians considered their domain: V8-powered touring car racing. Eventually, Australia abandoned Group A regulations entirely, creating a new V8 supercars category that effectively prevented the Skyline GTR from competing by mandating V8 engines. This wasn't a subtle change. It was an explicit admission that the only way to stop the GTR was to ban its entire formula. The rules specifically required 5.0-liter, naturally aspirated V8 engines and rear-wheel drive, a complete repudiation of everything that made the GTR dominant. It remains one of the most blatant examples in motorsport history of regulations being changed specifically to exclude one successful competitor. Similar rule changes occurred in racing series worldwide. The message was clear: if you can't beat the RB26, ban it through regulation. This wasn't just about one car being faster than others, it was about an engine and technology package so superior that it forced entire racing categories to rewrite their rulebooks. In the German DTM series, rules were amended to handicap all-wheel drive systems. In various touring car championships, weight penalties and restrictions on turbocharger boost levels were implemented specifically to rein in the GTR's dominance. The pattern was consistent. Wherever the RB26-powered GTR appeared, regulations would soon change to diminish its advantages. While the RB26DETT was being legislated out of professional racing, something else was happening that would cement its legendary status. It was becoming the heart of a forbidden fruit. The regulatory backlash against the RB26 in motorsport paralleled the way the engine was simultaneously becoming an object of desire for enthusiasts who couldn't legally obtain it. Nissan never officially exported the Skyline GTR to North America or many European markets. This created an aura of mystery around the car and its engine. Western enthusiasts could only read about this mythical Japanese supercar killer in magazines, or see it in video games like Gran Turismo, which introduced millions of players worldwide to the GTR legend. The gap between the RB26's reputation and its accessibility created an almost mythological status. Enthusiasts would debate its capabilities with almost religious fervor, despite most never having heard one in person. For many, the RB26-powered Skyline became the ultimate automotive unicorn, a car they knew existed but could never hope to experience. The RB26 became the centerpiece of car culture in places where the Skyline remained unobtainable. Its reputation grew to almost mythical proportions, especially in the United States, where strict importation laws, particularly the infamous 25-year rule, made legal ownership of an RB26-powered Skyline virtually impossible until recently. The engine became a symbol of Japanese engineering prowess, representing the pinnacle of the golden era of Japanese performance cars. In enthusiast circles, simply mentioning RB26 would evoke knowing nods and reverential tones, even among those who had never seen one in person. This scarcity only enhanced the engine's desirability. Gray market importers took enormous risks to bring Skylines into countries where they weren't legally sold. Underground tuning shops specialized in RB26 builds despite limited parts availability. The engine became automotive contraband, and like all forbidden things, that only made people want it more. Stories circulated of midnight street races where GTRs would show up and demolish local competition, only to disappear before authorities could arrive. Modern automotive folklore that enhanced the RB26's mystique. Some enthusiasts went to extreme lengths to experience the RB26, traveling to Japan specifically to drive GTRs on their native soil, or paying exorbitant prices for technically illegal imports that could be seized and crushed if discovered by authorities. The pop culture impact was enormous. When the Fast and Furious franchise featured a Skyline GTR in its films, it introduced the RB26 to mainstream audiences. The engine's distinctive sound, a high-pitched metallic wail unlike any V8 or V6, became instantly recognizable to enthusiasts worldwide. Video games like Need for Speed and Gran Turismo featured the Skyline GTR prominently, allowing virtual tuning of the RB26 and introducing a new generation to its potential. The car and its engine became symbols of automotive counterculture, representing the technical sophistication of Japan's approach to performance, as contrasted with the brute force methods traditionally favored in Western markets. Beyond its racing pedigree and underground cult status, the RB26DETT represents a pivotal moment in performance engineering. It embodied the philosophy of over-engineering that characterized Japan's bubble-era sports cars. This was a time when Japanese manufacturers were flush with cash from a booming economy and determined to prove their technological prowess to the world. The result was a generation of cars and engines built with little regard for cost-effectiveness, instead focusing on pushing the boundaries of what was possible. The RB26 stands as perhaps the ultimate expression of this philosophy, an engine where performance, durability, and potential were prioritized above all else. The RB26 wasn't just built to meet the requirements of the day, it was built with massive headroom for future development. Consider that with modern electronic engine management, updated turbochargers, and strengthened internals, the same basic engine architecture can reliably produce 3 or 4 times its original output. Few, if any, production engines have demonstrated this level of scalability. The fundamental architecture was so sound that even 30 years later, tuners continue to extract more performance from the basic design without requiring radical departures from the original blueprint. This isn't just good engineering, it's visionary engineering that anticipated decades of future development. Several engineering aspects of the RB26 were ahead of their time. Its closed deck block design with solid sleeves provided exceptional cylinder strength, a feature now common in high-performance engines, but relatively rare in the late 1980s. The casting process was exceptionally precise for its era, with particular attention paid to consistent cylinder wall thickness and cooling channel design. Modern computer-aided design and manufacturing techniques have validated many of the intuitive choices made by Nissan's engineers working with much more limited tools. The twin-turbo parallel setup predated the industry's wider adoption of multiple smaller turbochargers over single large ones for better response and power delivery. Today, this approach has become standard in performance applications, with even high-end European manufacturers adopting twin-turbo configurations for their flagship models. The RB26's implementation was particularly advanced for its time, with sophisticated wastegate control and careful matching of turbocharger size to engine displacement to minimize lag while maximizing top-end power. The individual throttle bodies offered precise air control typically found only in Formula One and other top-tier racing engines of the era. This technology would remain rare in production cars for decades after the RB26's debut, only recently becoming more common in ultra-high performance applications. The direct connection between throttle input and engine response created a driving experience that enthusiasts still celebrate for its immediacy and connection, a quality that many modern electronic throttle systems struggle to replicate. Its water-cooled turbochargers improved reliability and longevity, becoming a standard feature in performance turbocharged engines years later. This seemingly small detail represented a significant engineering investment but paid dividends in durability, allowing the RB26 to withstand prolonged high-output running without suffering from the heat-related issues that plagued many contemporary turbocharged engines. The attention to thermal management throughout the engine was exceptional, with optimized coolant pathways and careful consideration of heat transfer between components. The engine's ability to handle substantial power increases without major modifications to the block or rotating assembly set a standard for durability that many modern engines still struggle to match. The RB26 routinely handles double or triple its rated output with minimal strengthening, a testament to the margins built into every component. This wasn't accidental. It reflected Nissan's understanding that race engines need to be reliable under extreme conditions, and their decision to bring that same philosophy to a production car engine. Perhaps most importantly, the RB26 demonstrated that a relatively small displacement engine could deliver supercar performance through advanced engineering rather than simply increasing cubic inches, a philosophy that would eventually become mainstream as emissions regulations tightened globally. The 2.6-liter displacement seems modest by performance car standards, particularly in markets accustomed to large displacement V8s, yet the RB26 demonstrated that with the right technology, there were no inherent limitations to extracting phenomenal performance from a smaller package. This approach has since become the industry standard, with even exotic supercar manufacturers downsizing and adding forced induction to meet modern efficiency requirements, while maintaining or improving performance. If there's one aspect that truly cemented the RB26's legendary status, it's the engine's response to tuning. Few production engines in history have shown such capacity for increased output while maintaining reliability. This wasn't an accident. It was the result of Nissan's engineers building in substantial performance headroom to ensure dominance in racing. What they likely didn't anticipate was how this over-engineering would create a decade-spanning tuning culture centered around extracting ever more power from their creation. The tuning ecosystem that developed around the RB26 is unprecedented. Companies like HKS, Mines, Top Secret, and countless others built their reputations on extracting ever-increasing power levels from the RB26 architecture. What started as modest power increases soon evolved into a horsepower arms race. Specialized machine shops devoted themselves solely to RB26 builds, developing proprietary techniques for strengthening and enhancing the already robust platform. Knowledge was accumulated, refined, and passed down through a global community of tuners, creating a collective expertise unlike anything seen with other production engines. The progression was remarkable. In the early days, a 400-horsepower RB26 was considered heavily modified. Before long, 600 to 700 horsepower became achievable with upgraded turbos, fuel systems, and engine management. Today, fully built RB26 engines routinely produce 1,000-plus horsepower while remaining streetable. At the extreme end, drag racing specialists have extracted over 2,000 horsepower from the RB26 architecture, an astounding 8 times its original rated output. Names like HKS, JUN, Mines, and Top Secret became legendary through their development of high-performance RB26 variants, with specially built examples setting records at Tsukuba Circuit and other Japanese tracks. The engine responds so well to modifications because of its fundamentally overbuilt nature. The block can handle tremendous cylinder pressures before requiring strengthening. The oil and cooling systems were designed with significant overhead capacity. Even the factory connecting rods are famously robust, handling far more power than they were designed for. The stock crankshaft has been known to hold up to 600 to 700 horsepower without failing, extraordinary for a production engine component. This robustness meant that enthusiasts could gradually increase power in stages, learning the engine's characteristics and limitations along the way without catastrophic failures. This tuning potential created a global industry centered around a single engine. Specialized machine shops devoted themselves solely to building RB26 engines. Parts manufacturers continue developing new components for an engine that ended production decades ago. Performance shops worldwide still advertise RB26 builds as their specialty. From billet blocks to custom cylinder heads, stroker kits to specialized valve train components. The aftermarket for RB26 parts is more comprehensive than for many current production engines. The knowledge base surrounding the RB26 is equally impressive. Detailed guides exist for every aspect of the engine's operation and modification, representing a collective expertise built over decades of experimentation and refinement. Perhaps most tellingly, when building ultimate performance Japanese cars, many enthusiasts will swap other engines out in favor of an RB26, even when starting with a different Nissan model. The RB26 swap became a status symbol in itself, the ultimate upgrade for those seeking maximum performance from a Japanese platform. S-chassis Nissan sports cars, Z cars, and even non-Nissan vehicles have received RB26 transplants, spreading the engine's influence far beyond the Skyline models it was designed for. This cross-pollination has further expanded the RB26 community, creating unlikely alliances between enthusiasts of different car models united by their appreciation for what many consider the ultimate Japanese performance engine. After 3 generations of Skyline GTR, Nissan finally retired the RB26DETT when the R34 ended production in 2002. The next GTR, the R35, would arrive in 2002. 2007 with an entirely different engine, the RB26DETT, a 3.8-liter twin-turbo V6. The decision to move away from the legendary straight-six configuration wasn't made lightly. It represented a fundamental shift in Nissan's performance engineering philosophy and a recognition of changing regulatory and market demands. While the VR38 is undoubtedly a remarkable power plant in its own right, many enthusiasts still consider the transition from RB to VR the end of an era. The new engine was impressive technically, but something intangible was lost. The mechanical character, the racing pedigree, the raw nature of the straight-six. The VR38 brought greater refinement, better fuel economy, and cleaner emissions, but enthusiasts often describe it as lacking the soul and character that made the RB26 special. The distinctive straight-six sound was replaced by a more conventional V6 note. The linear power delivery became more digital and controlled, and the connection between driver and engine seemed somehow diluted through additional layers of electronic management. Some would argue that the VR38 is superior in every measurable way. More powerful, more efficient, more modern. But the RB26 had something that transcended specifications: soul. Its distinctive sound, throttle response, and the way it built power created a driving experience that many feel has never been replicated. There was an analog quality to the RB26's power delivery, a mechanical honesty that responded directly to driver inputs without the digital interpretation that characterizes most modern performance engines. The way it built boost, the surge of acceleration as the turbos reached full pressure, the metallic wail as it approached redline. These sensory experiences created an emotional connection that technical specifications can't capture. Nissan's decision to move on from the RB26 wasn't just technical, it was symbolic of broader changes in the automotive industry. Increasingly stringent emissions regulations, the push for better fuel economy, and changing consumer expectations all played a role in the decision to develop an entirely new engine architecture. The RB26 was a product of a different era, a time when performance and engineering excellence took priority over efficiency and emissions. As global regulations tightened and corporate priorities shifted, such single-minded focus on performance became increasingly difficult to justify. Yet the legacy of the RB26 lives on, not just in preserved skylines and museum pieces, but in the DNA of performance engineering. Its influence can be seen in subsequent engines, not just from Nissan, but from manufacturers worldwide who studied its successes. The trend towards smaller displacement, high-output turbocharged engines in modern performance cars owes much to the path pioneered by the RB26. Even as technology evolves, certain principles remain constant. The benefits of over-engineering critical components, the importance of thermal management in forced induction applications, and the value of an engine architecture with substantial headroom for future development. These lessons from the RB26 continue to inform performance engine design 3 decades later. Today, original RB26-powered Skylines, particularly the R34 GTR, command astronomical prices on the collector market. Cars that cost $60,000 to $80,000 new now regularly sell for $250,000 or more, with rare special editions fetching over $500,000. The most coveted variants, such as the Z-Tune and Nismo editions, have sold for closer to 7 figures, placing them in the realm of exotic European supercars from established marques like Ferrari and Lamborghini. This appreciation isn't just about the cars themselves, but specifically about the RB26 engine and what it represents, the pinnacle of Japan's golden era of performance engineering. This value appreciation isn't just nostalgia or scarcity, it's recognition of something special that can't be replicated in the modern era. The RB26 represents the pinnacle of an engineering philosophy that prioritized performance and potential above all else. Created during Japan's economic bubble when cost was a secondary consideration to technological advancement. Modern regulatory and business realities make it increasingly unlikely that we'll see production engines with such over-engineered potential again. The RB26 stands as an artifact from a unique moment in automotive history. When a perfect storm of economic prosperity, minimal regulatory constraints, and fierce competition created the conditions for something extraordinary. Even as newer, more powerful engines emerge, the RB26 maintains its legendary status for several reasons. Its sound, the distinctive high-pitched wail of a straight-six revving to 8,000 plus RPM through individual throttle bodies, is automotive music that resonates with enthusiasts across generations. In a world where forced induction often muffles engine notes and electronic throttle control dampens response, the pure mechanical symphony of a well-tuned RB26 stands out as increasingly rare and precious. Videos capturing the sound of RB26-powered cars at full throttle regularly attract millions of views online and introducing new generations to this distinctive soundtrack. Its character, the way power builds progressively before the turbos reach full boost, then the surge of acceleration as both turbochargers come online, creates a driving experience unlike modern, more linear turbocharged engines. This characteristic power delivery creates a sense of drama and involvement that many modern engines sacrifice in pursuit of predictability and ease of use. The RB26 demands something from its driver: an understanding of its power band, an appreciation for its quirks, and the skill to extract its best performance. This interactive quality creates a deeper bond between car and driver than many modern performance cars can achieve. Its modifiability: few engines offer such a direct relationship between modifications and results, creating a rewarding platform for enthusiasts to gradually build and improve. The RB26 responds to tuning in an almost linear fashion: more air, more fuel, more boost equals more power, up to the structural limits of its components. This straightforward relationship between input and output makes the engine unusually satisfying to modify, as results are tangible and predictable. The vast knowledge base and parts availability mean that almost any vision for an RB26 build can be realized, from a subtle street car to an all-out drag monster or precision track weapon. Its history, powering one of the most dominant racing cars ever created, gives the RB26 a competition pedigree that few production engines can match. The stories of the GTR's dominance in Japan and Australia have become automotive legend, passed down through generations of enthusiasts. This racing heritage gives the engine a credibility that can't be manufactured or marketed. It was proven in the crucible of competition against the best efforts of rival manufacturers. The fact that it was so dominant that rules had to be changed specifically to handicap it only enhances this legendary status. Being banned is the ultimate backhanded compliment. As classic Skylines become legal for import in markets that never received them officially, new generations of enthusiasts are discovering what makes the RB26 special. YouTube is filled with videos of people experiencing an RB26-powered GTR for the first time, their reactions capturing the magic that still surrounds this engine. The childlike wonder that spreads across the face of someone hearing the distinctive straight-six wail and feeling the surge of twin-turbo power delivery is testament to the RB26's enduring appeal. This isn't merely nostalgia. Something fundamental in the engine's character continues to resonate with enthusiasts born long after it was designed. The influence of the RB26 extends far beyond the cars it was originally installed in. Its engineering principles have shaped performance engines across the industry. The concept of building substantial headroom into production engines that would also serve as the basis for racing applications has become standard practice among manufacturers with motorsport aspirations. The RB26's parallel twin-turbo arrangement pioneered a configuration now common in many high-performance applications. Its overbuilt block architecture demonstrated the long-term value of excess strength in performance applications, allowing for continued development throughout a production run. Perhaps most significantly, the RB26 helped establish Japanese performance engineering as world-class at a time when European and American manufacturers still dominated the performance conversation. Along with contemporaries like Toyota's 2JZ GTE and Honda's B16/B18 series, the RB26 formed part of a Japanese performance trinity that forced the global automotive industry to recognize Japan as a serious player in high-performance engineering. The reputation established by these engines continues to benefit Japanese manufacturers today, even as specific technical approaches have evolved. The collectability of RB26 powered Skylines has reached unprecedented levels as the earliest R32 GTRs became legal for import into the United States under the 25-year rule. Prices skyrocketed as American enthusiasts finally gained access to cars they had worshipped from afar for decades. The appreciation has been so dramatic that even non-GTR Skylines with lesser RB engines have seen their values increase substantially. The ripple effect has impacted the entire Japanese classic car market, with the GTR and its RB26 leading the charge. Investment-grade examples of R34 GTRs are now treated as blue-chip collector cars, stored in climate-controlled facilities alongside rare European exotics. The secondary market surrounding the RB26 has become an industry unto itself. Specialized shops focus solely on rebuilding and tuning these engines, often with waiting lists stretching months or even years for high-end builds. Parts manufacturers continue to develop new components for an engine that went out of production 2 decades ago, indicating the sustained demand and enthusiast interest. From billet blocks to specialized turbocharger kits, carbon fiber intake manifolds to titanium exhaust systems, the range of available parts for the RB26 exceeds that of many current production engines. Modern technology has allowed the RB26 to reach performance levels its creators likely never imagined possible. Advanced engine management systems enable precise control over fueling and ignition timing. Computer-aided design and manufacturing techniques produce components with tolerances far exceeding what was possible in the early 1990s. Materials science has advanced significantly, allowing for stronger yet lighter internal components. The result has been a continuous evolution of what's possible with the RB26 architecture, with the engine remaining relevant in high-performance applications despite its age. The cultural impact of the RB26 extends well beyond car enthusiasts. The engine has appeared in countless films, television shows, anime, and manga. It has been featured in virtually every major racing video game franchise, introducing millions of players worldwide to its distinctive character and tuning potential. The sound of an RB26 at full throttle has become instantly recognizable even to casual observers. A high-pitched mechanical symphony that sets it apart from V8s, V6s, or even other inline-six engines. This cultural penetration has ensured that the legend of the RB26 reaches far beyond those who might actually own or drive an RB26-powered vehicle. Educational institutions have used the RB26 as a case study in engineering excellence. Its design represents a perfect storm of theoretical understanding and practical application, with solutions that remain relevant to modern engineering challenges. Students of automotive engineering continue to study its architecture, often comparing its approaches to those taken by contemporary engines. The lessons of the RB26, particularly its robust block design, advanced induction system, and thermal management solutions, remain valuable teaching tools even as specific technologies evolve. Preservation efforts have emerged to document and maintain the knowledge surrounding the RB26. As the original engineers who designed the engine retire or pass away, enthusiast groups and specialists have taken up the mantle of preserving the technical understanding that made the engine special. Detailed technical manuals have been translated from Japanese, original technical drawings have been archived, and interviews with key development personnel have been recorded for posterity. This grassroots preservation effort highlights the cultural significance attached to the engine beyond its technical specifications. Perhaps the most remarkable aspect of the RB26's legacy is how it transcends typical patterns of technological obsolescence. While most cutting-edge technology becomes outdated within years or even months, the RB26 has maintained its relevance for over 3 decades. This longevity speaks to how fundamentally sound the original design was and how much potential was built into its architecture. While newer engines may outperform it in specific metrics, the RB26 remains competitive in overall capabilities, especially when factoring in its response to modification and durability under stress. Comparisons between the RB26 and its spiritual successor, The VR38DETT, found in the R35 GTR, inevitably spark passionate debate among enthusiasts. The VR38 is unquestionably more advanced technologically, with direct injection, variable valve timing, and more sophisticated engine management. It produces more power and torque from the factory while meeting far more stringent emissions requirements. Yet many enthusiasts maintain that the older RB26 offers a more engaging organic driving experience. The VR38's power delivery is often described as clinical and digital compared to the RB26's more analog character. This subjective quality, the feeling the engine creates in the driver, demonstrates how performance engineering involves factors beyond measurable specifications. Professional motorsport continues to find uses for the RB26 in specialized applications. Time attack cars, drag racers, and drift machines often utilize heavily modified RB26 engines, taking advantage of their robust architecture and well-understood tuning characteristics. While series with production-based rules have moved on to newer engines, categories that allow more extensive modifications still see competitive RB26-powered entries. The engine's combination of compact dimensions, robust construction, and predictable power delivery continues to make it a viable choice for builders seeking maximum performance from a proven platform. The global community that has formed around the RB26 demonstrates the engine's cultural significance beyond its technical merits. Internet forums dedicated to RB26 development boast tens of thousands of members sharing information, troubleshooting problems, and documenting builds. Annual meets bring together RB26 enthusiasts from around the world, creating connections across languages and cultures united by appreciation for this remarkable piece of engineering. What began as a purpose-built racing engine has evolved into a cultural touchstone that brings people together through shared passion. As original B26-equipped vehicles age and become increasingly valuable, a restoration industry has developed to keep these machines running in factory condition. Specialists focus on rebuilding RB26 engines to exact original specifications, sourcing or remanufacturing discontinued components to ensure these historic vehicles can continue operating as intended. Nissan itself has recognized the importance of this heritage, establishing programs to remanufacture certain critical components for classic Skyline models. This institutional support for legacy products is rare in the automotive industry, and underscores the cultural importance of the RB26 and the vehicles it powered. The technical innovations pioneered in the RB26 continue to influence modern performance engines. Its individual throttle body design, once considered exotic, has become more common in high-performance applications seeking precise airflow control. The parallel twin-turbo arrangement has been widely adopted, even by European manufacturers who once favored single-turbo configurations. The closed-deck block design has become standard practice for high-output turbocharged engines. While technology has evolved, many of the fundamental approaches taken by the RB26's designers remain relevant in contemporary performance engineering. Performance benchmarking continues to reference the RB26 as a standard against which newer engines are measured, particularly regarding response to modification. When a new performance engine is released, one of the first questions enthusiasts often ask is how it compares to established platforms like the RB26 in terms of tuning potential and durability under increased output. This ongoing relevance as a point of comparison, more than 30 years after its introduction, speaks to the engine's lasting impact on performance engineering standards. As environmental concerns drive the automotive industry toward electrification, engines like the RB26 gain additional significance as examples of a distinctive era in performance engineering. While electric propulsion offers many advantages in terms of efficiency and immediate torque delivery, the mechanical character, sound, and emotional connection created by a purpose-built combustion engine like the RB26 represents something that may not have a direct equivalent in an electrified future. This realization has contributed to the increasing appreciation and preservation efforts surrounding these significant internal combustion engines as cultural artifacts worthy of preservation. So what's the shocking truth behind Nissan's banned RB26DETT engine? It's that sometimes excellence itself can be your downfall. The engine was so good, so dominant, so ahead of its time that regulations had to be changed to give others a fighting chance. Rather than being able to compete on equal footing, the rulebooks were rewritten specifically to handicap this technological tour de force. The RB26's story is a reminder that innovation sometimes faces resistance, not because it fails, but because it succeeds too well, disrupting established orders and forcing competitors to either adapt or change the rules of engagement. Yet in being banned, the RB26 achieved something more valuable than continued racing success. It became legend. Its story is one of engineering ambition meeting regulatory limitation, of technological superiority creating its own obstacles. The engine wasn't just good, it was too good for the racing categories it competed in. This narrative of excellence beyond convention has contributed significantly to the engine's mystique and lasting appeal. Being effectively legislated out of competition became a badge of honor, rather than a mark of failure. 3 decades later, the RB26DETT remains a benchmark against which performance engines are measured. Its combination of strength, tuning potential, character, and history created something that transcends its mechanical components. It's not just an engine, it's a cultural icon, a bucket list experience for enthusiasts, and a high watermark of Japan's golden age of performance cars. Few mechanical components achieve this level of cultural significance, crossing over from mere machinery to objects of desire and admiration across multiple generations. In an era of increasingly homogenized turbocharged engines, where even exotic supercars are beginning to sound and feel similar, the distinctive character of the RB26 stands as a reminder of what makes certain engines truly special. It's not just about power figures or lap times, it's about creating a mechanical experience that resonates on an emotional level. While modern engines may outperform the RB26 in specific metrics, they often lack the character and soul that enthusiasts find in Nissan's straight-six masterpiece. This emotional connection explains why RB26-powered vehicles continue to command premium prices and inspire passionate devotion decades after their production ended. The RB26DETT wasn't just banned from racing, it was too extraordinary for the ordinary rules. And that perhaps is the highest compliment any engine could receive. Its legacy isn't defined by the regulatory changes implemented to curtail its dominance, but by how it pushed the boundaries of what was possible within a production-based racing engine. By forcing the racing world to adapt to its superiority, the RB26 demonstrated its transformative impact on motorsport and performance engineering more broadly. The story of the RB26 serves as an inspiration for engineers and enthusiasts alike. A reminder that with sufficient vision, determination, and technical expertise, it's possible to create something that changes the game entirely. In an industry where planned obsolescence is increasingly common and development cycles are measured in months rather than years, the RB26's ongoing relevance stands as a testament to the value of over-engineering, robust design, and fundamental technical soundness. These principles transcend specific technologies and remain relevant regardless of the propulsion systems that may power future performance vehicles. Perhaps the most enduring legacy of the RB26 is how it serves as a bridge between generations of enthusiasts. Younger car fans who discover the engine through video games, online videos, or growing import scenes often find themselves connecting with older enthusiasts who experienced these machines when they were new. The shared appreciation for mechanical excellence creates connections across age groups, backgrounds, and cultures. In this way, the RB26 doesn't just represent a pinnacle of engineering excellence, but also a unifying force within car culture. A shared reference point that enthusiasts of all ages can appreciate and discuss with equal passion. The RB26DETT story reminds us that at its best, automotive engineering isn't just about transportation or even performance. It's about creating machines that inspire, excite, and endure. It's about pushing boundaries and challenging conventions. In an industry increasingly driven by cost considerations, emissions regulations, and homogenized global platforms, the RB26 stands as a reminder of what's possible when engineers are given the freedom to pursue excellence above all else. Its legacy isn't measured in sales figures or profit margins, but in the passion it continues to ignite in enthusiasts worldwide decades after its creation. As we look toward an automotive future dominated by electrification, automation, and environmental concerns, engines like the RB26 take on additional significance as examples of a distinctive mechanical era. They represent a time when the sound, feel, and character of an engine defined a vehicle's identity and created an emotional connection with its driver. Whether future propulsion systems can create similar emotional responses remains to be seen, but the RB26 has set a standard for mechanical charisma that any technology will be measured against. Its ongoing appreciation isn't mere nostalgia. It's recognition of authentic engineering excellence that transcends its era. The RB26DETT wasn't just another engine. It was a statement of intent, a declaration that Nissan could compete with and surpass the best in the world. It was so good that it changed the rules of motorsport, created a global tuning culture that continues to thrive decades later, and established a standard for performance engineering that few have matched. Its legacy isn't limited to statistics or race victories, but extends to how it makes people feel. The excitement it generates, the discussions it provokes, and the dreams it inspires. In the end, that emotional impact may be the most impressive achievement of this remarkable engine. If you enjoyed this deep dive into one of automotive history's most legendary engines, make sure to like this video, subscribe to our channel, and hit that notification bell so you don't miss our upcoming features on other iconic performance engines. Thanks for watching.